Hello dear students. In trick number 237, today we are going to continue some more questions, important questions of mensuration of three-dimensional figures. Now in this important video, I am going to deal with two types of combination of solids, different solids, wherein you need to find the surface area of the combined figure. Now as you can see here in the first question, there is a cylinder and it is surmounted by a cone. So a cone and a cylinder are joined together, and in the second question if you see, we have a cylinder in the middle and on both sides we have a hemisphere. So whenever you have these kind of questions wherein some solids are joined together, then you just need to understand how you go about solving these questions. First thing which you should remember is that all the figures which are combined have a common radius. Now obviously when a cone and a cylinder are fitted together perfectly one above the other, then they need to have the same radius. If they have different radius, then obviously this will not fit into this. Then here also you see the radius of hemispheres and the radius of cylinder is same. Now in the first question we have a tent in this shape, and in this question we are given that the height of this cylindrical part is 3 meters. So if I denote this height by h, so I have the height of cylinder as 3 meters, and we are given the common radii, that is 52.5 meters. This r is 52.5 meters, and slant height of this cone is 53 meters. So we have L as 53 meters, the slant height, and obviously this r is same as the radius of the cylindrical part. Both are 52.5 meters, and the height of the cylinder is 3 meters. Now what we are required to do is to find the total canvas required to make the tent. So if we have to find the total canvas required to make the tent, we just need to understand that canvas in a tent is used in the curved surface area of the conical part and curved surface area of the cylindrical part, because there is no canvas on the base because it is ground, and no canvas in the middle because that is joined together and that is the open portion of the tent. So if you have to find the area of canvas, then you just need to add the curved surface areas of the two figures. So CSA of cone plus CSA of cylinder. So if you know the formula of CSA of cone, it is pi r L, and CSA of cylinder, it is 2 pi r h. So children, don't commit the error of calculating the two curved surface areas separately, because when you calculate both of them separately you have to use the value of pi in both the cases. But if you write the formulas first and then take the common portion out, obviously pi will be common in both the terms, so you have to deal with pi only once if you write the formulas and then simplify it. So now you see here pi r is common and L plus 2h is the remaining part. Now the calculation will become very simple. See, pi is 22/7, r is, it is given 52.5, and L is 53, and double of height is 3, so it is 6. Now 22 into 7 and 52.5, they cancel out, so this is 7 sevens are 49, so 3.5, so that is decimal, and 5, and then multiply by 59. So now you can make these calculations very easily. I have already calculated this for you. So the answer for this, what you will be getting is this, these two when multiplied together will give you 165, and multiply by 59. So one more multiplication at the end to get the final answer. It is 9735 meter square is the unit of curved surface area. So the area of the canvas required to make the tent is 9735 meter square. Likewise, in the second question, you see, again we need to find the surface area of this solid. So if you have to find the surface area of this solid, then you have to again add the curved surface areas of the three figures, because the flat portion, that is this portion and this portion, it vanishes inside the solid. So we do not consider the flat surface areas. So we are left with only the curved part of the three figures. So in the solution, you have to find the surface area, which is equal to, see, we have the CSA of the this is cylindrical part, followed by double times the CSA of the hemisphere. So we have two hemispheres, so I have written double of the CSA of one hemisphere. Now again you have to take common, and if you take common, the calculations will be very easy. So you see 2 pi r, it is common, so we are left with h plus 2 and r. Now we need to know the dimensions what are given in this question. Now see, r is already given 3.5 centimeter. So apart from r we have only h. Now what is the height of this cylindrical part? Now you see this much, the one which I have drawn with dotted lines, this is actually the radius of this hemisphere, and this part, this is also the radius of this hemisphere. So if you need to calculate h, that is the height of the cylindrical part, then the total height is given as 19, and you need to subtract these two portions, this and this portion, and this is equal to the radius, and this is also equal to the radius. So if you subtract these two, then we are left behind with the height of the cylindrical part. So we have to subtract 2 radius. So 19 minus, what is the radius? 3.5. So 3.5 and 3.5 gives you 7. So the height of the cylindrical part is 12 centimeters. Now you need to put this value here. Now you see 2 into 22 by 7 into what is radius? 3.5. 3.5 is half of 7. So 7 by 2. Then h is 12, and double of radius is 3.5, so double is 7. Now you see 2 cancels out, 7 cancels out, you are left behind with 22 into 19. So 19 to the 38, 8 3 carry, 19 to the 38 and 3 41 centimeter square. That is the total surface area of this solid. You call it total surface area or you call it surface area, it is one and the same. So this is how you solve the problems related to the combination of solids, wherein you need to find the surface area. Now you see the number of steps which I have used in this question, it is just 4 steps, and here also I have used just 4 steps, whereas these type of questions usually come in easily 4 to 5 marks in exams. So children can learn this method. This is the exact way of doing this problem, and through these methods you can save a lot of time. In my subsequent videos I will be dealing with combination of solids in another video, wherein we will be dealing with problems concerned with finding the volume of this combination of solids. Till then, keep sharing and subscribe the channel if you like it.